Welcome to Science on Two Wheels. In this video, we'll be exploring the question, can we predict tornadoes? Let's get going. Okay, so as we should all know, tornadoes are natural hazards that can very easily become natural disasters. And to become a natural disaster, a tornado would have to cause widespread human, economic, material, or environmental loss. They can do a lot of damage. In fact, on average, each year in the United States, 80 people are killed and 1,500 people are injured. Because of the damage that tornadoes can cause to all of those different things, people have been trying to mitigate the damage from tornadoes for hundreds, thousands even of years. And one of the main ways that we've come up with to mitigate the damage from tornadoes is to make stronger structures, and then have structures such as basements and cellars, things like that, to where we can get away from or withstand the strength of tornadoes. Now, the problem with that, of course, is that people who are caught out in a tornado, a stronger structure isn't going to do anything for them, right? You have to know that the tornado is coming sometimes in order to get to your secure location in order to, not be killed by this angry vortex of wind. So, because of that, one of the best ways to mitigate human loss especially is to be able to predict those tornadoes ahead of time. Before we really get into whether or not tornadoes can be predicted and how, let's talk about what tornadoes actually are and how they are measured. Tornadoes generally happen in the midst of or alongside a thunderstorm. So the NSSL, that's the National Severe Storms Laboratory, defines a tornado as a violently rotating column of air that extends from the bottom of a thunderstorm down to the ground. They also occur in the United States more than in any other country in the entire world. In the United States alone, there are generally about 1,200 recorded tornadoes each year. The problem with that is that we don't actually record many of the tornadoes that occur. And that means, of course, that there are probably quite a few more than just 1,200 tornadoes a year. Tornadoes are measured using something called the Enhanced Fujita Scale, or EF scale. Here it is, in fact, for your viewing pleasure. As you can see, the EF scale ranges from level 0 to 5, with 5 being the strongest. EF0 tornadoes can have winds as low as 65 miles per hour, and EF5 tornadoes have wind speeds of over 200 miles per hour. As with most natural hazards, the key to predicting or forecasting them is to understand them and how they work, how they form, how they occur. With tornadoes, that's a bit tough because we don't fully understand. The National Severe Storm Laboratory says that tornadoes most often form when there are two different air masses of very different temperatures colliding. However, they often form without those two different air masses and without those two different temperatures. So we still have quite a bit to learn about them. That being said, one of the first steps that meteorologists take in order to predict or forecast a tornado is to look at historical data. As you can see in this map from ustornadoes.com, tornadoes most often occur in specific areas. For example, in Texas, there were an average of 44 tornadoes each year during the month of May from the years 1991 to 2015. During that same time period, Florida only had an average of 2.7. In fact, this approximate area in the oval is often referred to as Tornado Alley because of how often tornadoes occur there. Now that meteorologists know where to look the most, one of the first tools that they use is something called a Doppler Radar. So a Doppler Radar is really cool because not only does it show storms, clouds, precipitation, things like that, but it can also tell meteorologists what direction those clouds are moving in and how fast. They use these Doppler radars to find something called a hook echo. A hook echo really is kind of what it sounds like. It is when the clouds, the storm clouds in the air, they move to form a hook. Here's an example of a hook echo on a Doppler radar image. If you look at the area circled in red, you'll notice that the colors create a hook shape. This indicates an area of spinning air called a mesocyclone, which has a high chance of turning into a tornado. If a hook echo is detected in this way on a Doppler radar, meteorologists will issue a tornado warning. This way, they can give people a warning of up to 13 minutes ahead of time. Another way that meteorologists use to predict tornadoes is to look for certain types of clouds that can indicate good weather for a tornado formation. One of those clouds is called a beaver's tail cloud. These clouds suggest the presence of rotating air, which can indicate a tornado. Another type of cloud is a wall cloud, which indicates, again, rotating air. These types of clouds usually exist around 10 to 20 minutes before a tornado actually forms, if a tornado forms at all. It's important to remember that wall clouds are not shelf clouds, even though shelf clouds look like giant walls coming at you. Shelf clouds indicate an incoming storm and can stretch across an entire horizon. Wall clouds, on the other hand, are much smaller, like in this picture. Finally, and probably the most famous kind of cloud associated with tornadoes, is a condensation funnel, or funnel cloud. These clouds are not touching the ground. However, if a condensation funnel does extend to the ground, it then becomes a tornado. Alright, so those are the main ways that meteorologists can predict or forecast a tornado. You've got historical data, you have Doppler radar looking for things such as hook echoes, and you've also got certain types of cloud formations that can indicate a higher risk for a tornado forming. I hope that this video helped you understand or answer the question of whether or not we can predict tornadoes and how we are able to do that. If you liked this video, please give me a thumbs up, click on that subscribe button, click on that fancy little bell icon if you would like to get notifications. Thank you. Come back and watch more.